Hey everyone, we're Group 1, and our case is can cars drive themselves, and should they? My name is Will Ard.
My name is Monique Allen.
My name is Quentin Bell.
And I'm Will Blavos.
Now I'm going to hand it over to Monique to go over kind of a roadmap for what this presentation entails.
So our expectation profile to you, what our slideshow is going to cover, we called this the roadmap. We thought it was appropriate to introduce a brief history of self-driving cars, describe various challenges that the industry is facing, provide updates for outdated information, answer the question, is this considered a good business investment? Discuss ethical and social issues regarding self-driving cars, and answer another question, will cars really be able to drive themselves without human operators? So on our next slide, we're going to talk about a little bit of the history of self-driving cars. They're quickly becoming a top choice in transportation for many consumers. There's fierce competition among major automakers, and this competition helps to drive the development of innovative technology. So on our next slide, Will B is going to discuss the context and content.
Hi all. So automakers today are racing to develop the perfect autonomous vehicle on the expectation that the future demand and will be in the trillions of dollars. So we have laid out here, you have a graph of the current, a snapshot of active autonomous vehicle patent families by automaker. So just a quick note, you'll notice that Tesla is missing from this. So Tesla in 2014 decided to make their patents open sourced for the betterment of society. So just a quick note there. So some challenges of a fully autonomous level. So that's a level 4 or level 5. So on the left-hand side, you'll see the levels broken out and kind of just a brief, quick description of what that entails. So level 4 and level 5 are fully autonomous. So Pew Research within the case showed that 87% of consumers did not know if autonomous vehicles were safe, and they wanted a human behind the wheel. So these are a couple of the things that are challenging to the industry itself. So these vehicles don't operate well in poor weather conditions or if the roads are marked poorly, and they can't properly account for things like overhanging tree branches. Additionally, there's a lack for scene understanding. So an example of this would be a plastic bag in the roadway. Is that plastic bag full of bricks or is it full of air? So the systems today cannot differentiate between the two. A couple other challenges, merging. So merging is something that requires nonverbal communication between two drivers. So today, those systems can't conduct that communication with other cars because most cars on the road do not have advanced technology. So when those systems do get that advanced technology, those systems will be vulnerable to bad actors. So people that either want to use their car for something illegal, or they just want to generally cause havoc with the cars. The infrastructure today is not designed to fully accommodate full autonomous vehicles. So changes over time will need to be made to our highway system and roads. Waymo is a maker that is taking steps to accommodate for this. So they have partnered with Avis for their fleet management. Another big problem is that the amount of mapping that is required for these vehicles today doesn't exist. And so when they are first released, it's all likelihood that they will have a predetermined area where they can operate in, and there will be predetermined spots for pickup and drop off. Next, Quentin is going to discuss what's been updated from the case.
Thanks, Will. So from what we've seen, most of the major players in the automobile industry are still continuing to make pushes or strides towards production of fully autonomous cars. So for example, Ford had initially planned to start producing autonomous cars in 2021. However, due to the pandemic, this has now been delayed until 2022. However, they have recently announced that in the new Ford F-150 that is being released, they would push software that would allow updates to be made over the air. So Nissan is in the process of testing out their autonomous vehicle, which would be the Nissan Leaf, and they seem to be having success. Their self-navigating car has successfully driven itself 230 miles, which is being touted as the longest and most complex journey that has been done in the UK. During this test, two engineers were present in the car. However, their goal of 99% self-navigation was achieved. In January of this year, General Motors made an announcement that they would begin testing the Origin, which would be their version of the autonomous vehicle in the near future. However, in May, they announced that they will be cutting 8% of the workforce that is employed to work on this vehicle. But they have said that this layoff is not due to the coronavirus pandemic. And last but not least, just this month, Mercedes announced their partnership with NVIDIA. And the idea behind this partnership is that they would deliver software-defined vehicles, which would allow software updates to be made over the air also, and also help them move closer to a fully autonomous vehicle. So next, we will pass it over to Monique, who will be talking about challenges from the management, organizational, and technology realms.
Thank you. In this slide, we will address the question of what are the management, organizational, and technology challenges posed by self-driving car technology. I found several challenges for each category during my research in this case study. So we'll start off with the management. We want to know who's liable in case of consumer accident and death. There's also the challenge of reducing labor costs for Uber and Lyft. The next section for organization, there's the high cost of R&D investment. That's a big challenge. And also the challenge of federal government creating laws to regulate autonomous vehicles. And last, we have the technology sector. There's difficulty operating in severe weather conditions such as heavy rain or snow. And also security is an issue. Keeping systems safe from intruders has been a big deal with self-driving cars. Like, how do you keep them safe? And next, I will go to Will B. Again, he is going to discuss our self-driving cars' good business investments.
Thank you, Monique. So the investment in autonomous vehicle technology, I would say, is neither good or bad for business. It's absolutely necessary. So the firms today that manufacture cars need to ensure their future, and so they need to ensure that their vehicles contain this this technology. So whether it is today, they should be cautious with whether or not they are willing to invest to a fully automated vehicle, so a level 5 vehicle, because as we represented earlier, consumer sentiment, consumers may not feel totally comfortable today and possibly ever with having a fully autonomous vehicle. So what they do need, what consumers have shown is that they are comfortable with a level 2 driving autonomy. So these are the lane keep assist features, adaptive cruise control, the features that will stop a car at low speeds to prevent you from hitting an animal or a person, assist you in preventing you from changing lanes. So the investment in those minimum features is extremely important for manufacturers of cars today. It has to happen for them to be able to maintain their position going forward globally. Next, Quentin is going to finish up and talk about, Will is going to talk about the ethical and social issues raised by self-driving car technology.
Thanks. And I'm mostly going to talk about this through the lens of an alternative. And that alternative is the bus system. America has this obsession of technology and the idea that we can innovate our way out of traffic. The industry tends to focus on personal access rather than public access. And traditionally, individuals like Elon Musk, who's the CEO of Tesla, see public transit as an entirely different market than personal vehicles, when it's really an alternative. This could be an American-specific perspective because we see classism in our bus system. It's a signal more of economic failure, but this isn't the case in many other countries. So if we want to move to a bus system, which I'm about to outline some reasons why, we really need to change our perception of buses. So this idea of innovating and creating something brand new has its limits. For example, I mentioned that Elon Musk kind of sees the self-driving cars and public transit as separate opportunities. He proposed a Hyperloop, which is it's like a tube that goes in the ground and can propel people insanely fast. And it can move 2,000 people per hour. But just adding a transit lane in our cities could move 10,000 to 25,000 individuals per hour. So, like many innovative prospects, the self-driving car industry is posed to benefit a few before reaching a more mass audience and never reaching some people. It's clearly a design decision that's going to limit the number of users and, by extension, limit the number of individuals who are going to benefit. And we kind of see that just all across the board in transportation. Again, with buses, wealthier transit riders pay less because they can afford monthly passes and subscriptions, but those who can't afford that are stuck buying a ticket every single time they get on. The environmental impact of autonomous vehicles is somewhat overstated. It'll definitely make a difference, but if we move to a public transit system, there would be far less vehicles on the road, which would serve a higher ratio of individuals at the same time. And that would lead to a reduction in energy it outweighs the self-driving car. It would also reduce the number of cars. So if we had autonomous buses, there would be less traffic, and the sensors that we're currently using would have an easier time being able to sense. Next, I want to talk about the work culture of autonomous vehicles. When we no longer have to drive, there's nothing stopping people from working basically all the time. And we started to see that when Apple and Google unveiled their bus systems for their employees. And on top of that, when that happened, there was a big public backlash because in California, the public transit system isn't up to par like most of America. And there were not necessarily riots, but protests against the Apple and Google buses in 2018, where people would just leave Lyft and Uber scooters surrounding the buses to where they couldn't move. We also have to look at data collection. The companies who are interested in this market, such as Amazon and Google, are some of the largest data analytics and tracking companies in the world. So if they control transportation, well, that helps them collect even more data and potentially use it in a harmful way, such as just targeting susceptible individuals and furthering our bias bubble online. I'm going to hand it over to Quentin to kind of talk about the future of self-driving cars.
Thanks, Will. So through all of this, there is one question that remains, and that question is: will and should autonomous cars, or will and should cars fully be able to drive themselves without human operators? And as we see throughout this presentation, the answer to this question can become very complex, which leads to a lot of gray area. For instance, you would have to think about legal implications, as well as just many areas of technology. But as we've seen, strides have been made in the direction of having a fully autonomous car. An example of this is a lot of automakers are implementing technologies such as self-parking and collision detection, and lane departure detection. And then, some other benefits that are being argued about these cars is that they could potentially lead to reduced traffic, as Will mentioned earlier, and as well as decreased transportation costs. And on an even larger scale, some studies have shown that these cars could potentially decrease carbon dioxide emissions by 80% worldwide. But on the opposite end of this spectrum, some very strong arguments are being made as well. So for instance, some people question, are these cars really safe? An example of this is in 2018, a self-driving Uber struck and killed a woman in Arizona. And then also another example is in 2016, a Tesla hit an 18-wheeler. And with these examples, they can lead to questions such as, how can these cars determine what the human is doing inside of the car, and also give them enough time to react and take over if needed? And in the case of accidents, who will be held liable? Would it be the manufacturer of the car, the developer of the artificial intelligence software, or would it be the human inside of the car? Some other questions that have been raised is, for instance, when humans drive, there are a lot of subtle and nonverbal communication cues that take place. And in the case of fully autonomous vehicles, how would this be implemented in regard to things such as lane changes and merges? Weather also is a huge factor, such as heavy rain or snow. They cause low visibility, and would these cars be able to handle these situations? And finally, how would these cars be regulated? Would they be regulated on a federal or state level? And if they're regulated on a state level, would these cars be allowed to cross state lines due to varying laws? So with all of this considered, and how technology is constantly evolving, we do think at some point that these cars will become highly present and available. However, there are many, many challenges that have to be addressed and researched in depth before the customer truly trusts these cars. That is the end of our presentation, and we hope you enjoyed.